Alrighty, y'all. So first of all, welcome back. I hope everyone had a nice break, and we are right back into it. So we started learning about what is called the unit circle last semester. So it was a little bit rushed, and we kind of pieced a few things together, but we didn't really flush it out completely. So that's what we're going to do today, and let's go ahead and start talking about it. So let's go ahead and begin with the original concept. Okay. Now the unit circle, it's called a unit circle because what we're doing is we're working with one unit as the radius of the circle. So we're gonna go ahead and label that as 1, right? So the radius is just from the center to the edge of the circle, and we're gonna go ahead and say that that length is 1. That's the circle that we're working with. Okay. So in the unit circle, the radius is 1. Cool. So for any point x comma y on the unit circle, 1 is equal to the square root of x squared plus y squared. Now, what that comes from is that's just the Pythagorean theorem. So let's visualize that. We make a right triangle here, right? And then what you end up with is this is your y coordinate. So this is a point, right? So let's go ahead and talk about what the coordinates are for that point. So it's an x comma a y, right? Just like every other point. Okay, so on this particular one, whoa, let's zoom in here. All right, take a little bit better of a look at it. Okay, on this particular one, so we've got this as your, this is your y coordinate, okay, and then this length is your x coordinate. Now, I'm specifically talking about like this length here, right, and then this length here, okay? And that's what we're working with. So the trigonometric functions for this particular angle, okay, well, let's go ahead and develop each one, okay? We know sine to be, as a reminder in case you need it, right? We've got SOHCAHTOA, the acronym that we use for sine, cosine, tangent. Cool. Sine is equal to the opposite over the hypotenuse. So what is my opposite side when compared to theta, that angle? Well, the opposite side would be y. Okay, so it'd be y over the hypotenuse, but what's my hypotenuse? It's 1, right? So it's just y over 1, which is just y. Okay, so it's just sine of theta is equal to y. Okay, we'll do the same thing, but with cosine. Okay, so cosine of theta is equal to the adjacent over the hypotenuse. Well, the adjacent side, it happens to be x. So it's just x over that hypotenuse side, which is just 1. So it ends up just being x. Okay, and then with tangent's a little bit different. Okay, we've got tangent is just the opposite over the adjacent, so it's the opposite over the adjacent, so it's y over x. Okay, so this one ends up being y over x. We'll use that line as your fraction. Okay, so y over x. Okay, so the implications that this has is extreme. Okay, so essentially what we're now saying is that if any angle, right, the sine of that angle in the unit circle is just equal to y. Cosine of an angle in the unit circle, right, is just equal to your x. So this coordinate up here is actually equal to, in other words, cosine of theta, right, that coordinate is equal to the cosine of theta and for your x, and then your y is the sine of theta, all right? And that's huge in what we'll be working with. Okay, let's go ahead and fill in cosecant, secant, and cotangent. Essentially, right, all we're doing is flipping these, right? Cosecant is the reciprocal function of sine, so it ends up just flipping, so 1 over y. Okay, over here, 1 over x, and then over here, x over y. Okay, now, that is great and dandy for this first quadrant up here, okay? Should make sense for the most part, okay? Got it, your tangent, or your sine of theta, right? Y over 1, cool, makes sense. Okay, but what happens when we go over here? Let's visualize that for a little bit, okay? Now we've got an angle that spans like this. So it's like, let's get another picture going. Okay, so you've got your x and y axis, you've got your unit circle, and let's say we're trying to find this over here, where this is all your theta. Okay, So what ends up happening is we're actually going to expand the definition of what we know of an angle, right? Before we were working with angles that are just like those acute angles, right? But this is your angle, okay, for theta. Now, in general, okay, if I were to ask you what the opposite side of theta is now, it gets a little bit confusing, okay? Or if I were to ask you what the opposite, the adjacent side is when compared to theta, it again gets confusing because we don't have this nice like triangle like we had over here. It gets a little bit funky over here. But what essentially what we're doing now is when we do expand outside of quadrant 1, when it's not just working within this, we're actually going to expand the definition to, okay, no matter what, my sine of theta is equal to y. No matter what, my cosine of theta is equal to whatever my x coordinate is there. Okay, so we're actually going to expand that definition with sine theta, cosine theta, and tangent of theta. Okay, so from here on out, right, if it's, let's give this an actual angle. Let's give theta, let's say it's like 150. Okay, if I ask you what the sine of 150 is, right, you're actually going to tell me the y coordinate of the unit circle there. Okay, and so that's what we're working with when we expand that definition of sine and cosine of theta within the unit circle. Okay, using that logic, we can now start to formulate the unit circle. Okay, so we're going to actually go ahead and jump in and start. Okay, so looking at this right here, okay, is where we're going to begin. And here we are. So if you think back to what we were doing before, okay, I filled in some of this already, all right, because these pieces we've already done, right? We already talked about these angles in here. I'll tell you now, these are your degrees, right? 0 degrees, 30 degrees, 45, 60, 90. We've done this in the middle. Okay, we also learned how to convert to radians. That's what this is on the outside. Okay, so I've got two different pieces filled in on my unit circle. Okay, I've got the degrees on the inside, and I've got the radians on the outside. Okay, don't forget, radians is just a different way of measuring an angle. Okay, now we're also going to use this key here in order to help me talk about what is going on like with this. So essentially what we're doing, guys, is we're going to fill in each of these blanks. We're going to fill in every single one. It looks daunting, but once you get one of the quadrants, you can actually fill in the rest pretty easily. Okay? Now, we're just using that same definition that I just talked about. Right? We're going to talk about what the x and y coordinates are here. That's what this is. So it's x comma y. Right? I'm going to put my x coordinate here, my y coordinate here, and then here I'm going to actually put my tangent value. Okay? And that's what it has here, right? Because we just learned cosine of theta is your x. Sine of theta is your y. Okay? Where was it? It was here. So sine of theta is your y. Cosine of theta is your x. That's exactly what we have here. Now, it seems a little bit backwards because you're so used to seeing sine of theta first. Okay? But don't forget, cosine of theta is your x. Okay? Cosine theta x. Sine of theta, y. Okay? And then on the outside, again, tangent is going out here. Okay, another important thing to note, right, and we had talked about this here, okay, is that tangent of theta is actually equal to y over x. Well, using that definition, okay, tangent of theta is equal to y. Well, what's y? Y is sine of theta. Okay, so we're actually going to, and then cosine, or sorry, x is actually cosine. So it ends up being sine of theta over cosine of theta. That's what this is. So don't forget, all we're doing here to find the tangent of theta, it's equal to the sine of theta over cosine of theta, or in other words, your y over your x. Okay, so let's go ahead and begin to fill this in right now. But one more thing I want to mention is that we've actually sort of done some of this. Okay, we've done some of the bulk of the work, but essentially, to rewind you back to one of our lessons last semester, we filled out a table like this. Okay, now all we did here is we set up 30, 60, 90 triangles where the hypotenuse was 1. Okay, that should ring a bell, right? Because what was your hypotenuse when we were talking about this right here? Your hypotenuse was 1. Okay, so that's actually why we did this activity. Same thing here, 45, 45, 90 triangles where your hypotenuse was 1, and we ended up getting all these values in this table. Okay, now this is where they're actually going to come into play. Okay, because now we're actually going to use this knowledge to help us find some values. Okay, and let's go ahead and start. So I'll reference this in the beginning, but here we go. okay? And let's do the simple ones first. Let's go ahead and do the 0, the 90, the 180, and the 270, okay? Let's make it nice and simple here. Okay, we know my radius in the unit circle is 1, right? So just to reemphasize, that's this length to this length. That's this length to this length is 1. That's this length. Anytime I connect the center to the edge, the length is 1, okay? With that logic, let's think about what this coordinate right here would be. All right, well, what is your x? Your x would be 1. What is your y value at that coordinate? Your y value would be 0, okay? And then filling in the tangent here, okay, well, let's think about it. If the tangent, theta, right, and in theta here, your angle is 0 or 360 for degrees, your angle is 0 or 2 pi for radians. But theta, or tangent of theta, is going to be equal to your y over your x. Well, what is your y? Your y is 0, your x is 1, so this whole thing is going to be 0 over 1. In other words, it's just 0. Okay, so that's starting off, we've got our first one. Let's go up here. What's my coordinate up here? Again, these are coordinates. Okay, so we've got 0, 1 up here. All right, this time your y is positive, is that 1, and then your x is just still 0 because this is the origin. That'd be another important thing to note, maybe. But that coordinate right there in the very center is 0, 0, 0. Okay, now this time let's think about tangent of theta, right? Again, tangent of theta is equal to y over x. So it's 1 over 0. 1 divided by 0. Can you divide by 0? No. So this is undefined. Okay, we've now found remember, cosine of 90 is now 0. Sine of 90 is now 1. Tangent of 90 is undefined. Okay, that's how we're going to use this table. All right. And essentially what it means is now, because of this table and because of the patterns, I can ask you, what's cosine of 150? And you're going to be like, oh, cosine, that's here, and you should know it. That's our goal. That's where we're going. Or tangent of 240, well, what's here? Got to know it, okay? And again, there'll be patterns. It'll be easier than it seems, but it is a lot. But again, the patterns help us big time. Here we go on this one over here. Now we're working in the negatives for my x now. Okay, something to keep in mind, right? This is 0. Well, now my x coordinate here, -1. Okay, my y coordinate, 0. Okay, we end up with our tangent, right? It's the y over the x. So this time it is going to be 0, okay, because it's 0 over -1. Down here, okay, 0, comma, -1. Again, that's the coordinate at that particular spot right there, okay? And it's 0, -1. What do you think the tangent is going to be? Well, because my tangent of theta is y over x, it is y over x, so we can't divide by 0. This is once again going to be undefined. Okay, now let's fill in the rest. Okay, let's go ahead and start with red here. All right, now we're going to use this table to help us. Okay, we're going to use this table to help us. Let's zoom out a little bit so we can really see the entire thing. Okay, so here's what we'll start with. We'll start with the 30. Okay, now this table, again, we've developed some of this. This will be helpful in the beginning, and then I'm going to get rid of this table because it might get too confusing. But we're looking at 30 degrees, okay, and I want to start off with my x, which is, again, my what? That's my cosine, okay? X is cosine, y is sine, okay? So x, cosine. So cosine of the angle, 30, that's square root of 3 over 2. Now, if you need help with remembering where we got this, it's not the world's most important thing right now, but essentially what it is coming from the 30, 60, 90 triangle process and the 45, 45, 90 triangle process. If you need a refresher, if you're really curious, you can go to this lesson right here, which is what we did, something we did in last semester, and it can, in that video, I kind of take you through the process of how we got each one of these. Okay, so if you're extremely concerned about where those numbers are coming from, go look at that video. All right, so that first one, what that's telling us is cosine of 30 degrees is the square root of 3 over 2. So that's what we're going to fill in right here. Square root of 3 over 2. Okay, and we're going to put that in as my x coordinate. What's my y? Okay, well, this time it's going to be sine, right? Because sine is my y. So of 30 degrees, it's 1/2. And then what's tangent? Well, tangent of 30 degrees, that is the square root of 3/3. Okay, so we got our first one. All right, we got our first coordinate. So again, what this is saying is at 30 degrees, right, what are the coordinates? Okay, my x-coordinate is the square root of 3/2. My y-coordinate is 1/2. My tangent, not a coordinate, it's just your tangent of that angle, is the square root of 3/3. Okay, cool. Let's go to this one. Now, what's nice about this one, okay, at the 45, on the next one, let's get a new color. Okay, we're going to do this one in blue. What's good about this is look at the table, okay? 45 degrees, square root of 2/2, square root of 2/2. So it's actually the same. So I just need to write that twice, right? And it makes sense if you think about it, right? If it's a 45-degree angle, right, like this length from here to here is the same as here to here, okay? Because it's a 45, 45, 90 triangle, okay? And then also what's nice about your tangent, okay, is that it's y over x, right? Your tangent, theta, is just your y over x. Well, this over this, anything over itself, that's 1. 60 degrees. Okay, notice these are flip-flopped. That's exactly what happens here. So 1/2, 1/2, right? And then, right, the sine and cosine are flipped. So with that logic, okay, if this was your cosine earlier, okay, it's now going to be your sine, so that's going to end up here, and then this is going to end up here. Let's go ahead and write it with the correct color. That is going to be 1/2 for the first one, and then the second one, square root of 3/2. And then right here, okay, let's look at it. It does change a little bit. Technically, yes, it's this flipped, okay, this flip, but what ends up happening is since you can't have a radical on the bottom and everything like that, it ends up just being the square root of 3. Okay, so promise it gets easier from here. This is now where I'm going to get rid of this table. I'm not going to look at it again. It's irrelevant because once we fill out this first quadrant, like I've been saying, the rest gets way easier. Okay, so think about what these are. These are coordinates. Okay, these are all coordinates. Maybe you don't understand where they're from, like exactly where they're coming from. But from here, if you know these, you can probably see the pattern. So let's just go over to this one up here. Right? So let's just compare these two coordinates. Okay? Just in general, right? Think about which one should be the same. All right? Think about which one should be the same. Now, your y coordinate should be the same, right? Because look at it, right? They're the same height. Okay? They're the exact same height. Well, that's your y coordinate. So you're just going to keep that one the same. It's going to be the square root of 3/2 over here. Square root of 3/2. Okay? And then let's think about our x coordinate. Well, we have this, right? We know it's 1/2. Okay? It's 1/2 here. Now it's just 1/2 here. Well, this is positive. This is negative. So now it's just negative 1/2. There it is. Okay? And again, similar logic. Y over x. Well, this was y over x, right? Y over x ended up giving you the square root of 3. Well, so it's still the square root of 3. But what's the one difference? Well, this time it was earlier it was a positive over a positive, get you a positive. Now it's a positive over a negative, so it should get you a negative. Okay, there we go. There's our first one. Let's just continue a similar pattern and just fill in all of our green ones. Okay, let's try that. All right, down here. Where are we at? So this is up here, okay? And the green one, it's just consistently, we're going from here to here, okay? So the same x-coordinate, okay, same x-coordinate, and we're going to kind of reverse, right? So it'll be like red, blue, green, and then it'll be green, blue, red, and then it'll be red, blue, green, okay? Just how I'm doing it, okay? And then from here to here, so again, same x-coordinate. Still going to be negative 1/2. Okay, that distance, square root of 3/2. Well, it was positive here, but negative down here. Okay, so there it is. Again, same logic. I'm going to have the square root of 3 here. Is it positive or negative? Let's think. Well, here it was positive over a positive, which gives me a positive. Positive over a negative, which gives me a negative. Negative over negative, which gives you a positive. Okay, so the sign doesn't change there. All right? From here to here, same y coordinate, both negative. Okay, this time your x coordinate, though, positive, right? Positive, and it was negative 1/2 here, but if I'm going this way, now positive 1/2. Okay, this over this, it's a negative over a positive, so therefore it's going to have that negative square root of 3. Okay, cool. We've taken care of that. Let's do blue. A very similar logic. This one's even easier, though, because look at blue. It's my 45, 45, 90. So if you want, let's do it one at a time. We're not going to get too far ahead of ourselves. Okay, so it's this coordinate compared to this one. Your y coordinates are the same. So it's the square root of 2 over 2. Your x coordinate is negative, though. Okay, so it's just negative square root of 2 over 2. Positive over positive got you that positive 1. Positive over negative, negative 1. Okay, that was this one. Now we're down here. Okay, notice these are both negative, right? Negative x, negative y. Okay, so negative square root of 2 over 2, negative square root of 2 over 2. This is a negative over a negative. That's going to give me a positive 1. Last blue one, over here. Okay, we've got, let's just think about that in general. Your x coordinate's positive, your y coordinate's negative. It's below that x axis. So we've got positive x, negative y. And negative over positive, so this is going to give me negative 1. Last one, here we go. Red, okay, you've got your square root of 3 over 2, okay? You could literally just write all that stuff, right? Maybe that's another approach if you want to take that. Write the same thing, same pattern, you just change some positive and negatives, okay? This one, your y's got to be the same because it's here and here. Your y is the same, but it's just a flipped sign for your x. So there it is, and this is a positive over negatives. So that's a negative. Down here, okay, this is your changing your y from here to here. So it's negative square root of 3 over 2, and also negative 1/2. And then you end up with a positive, right, because it's a negative over a negative, positive square root of 3 over 3. Last one, filling out the entire unit circle. Here we go. And I'm going to compare it to this one. Your x is the same sign, so it's the square root of 3 over 2, but negative 1/2. Then you end up with negative square root of 3 over 3. And that is the unit circle. Okay? And again, what this represents is it represents your x and y coordinates at each of these angles. Okay? It's a lot. Okay? I'm not even going to pretend like it's not. But there are patterns. Okay? And if you can understand those patterns, you can piece the rest together. Now, notice, I don't look at this and say, I just like right off the top of my head, what is sine of 3 pi over 4? Okay? Now, I've got to visualize it, me personally. Okay? And I think about, okay, where's 3 pi over 4? Well, I know from here to here, it's pi. Okay, so I know now 3 pi over 4 is right here. Okay? Now I've got to think, oh, what was asked? Well, if it was sine is my y. Okay, so what's my y there? Well, my y would have to be positive. I know it's one of those ones that's a 45, so I know it's the square root of 2 over 2. Okay, that's the process, that's the visualization that has to take place in your brain. Now, another huge trick, okay? I'm actually going to go ahead and just draw this triangle right here, because I think that's the most important one, okay? Let's just visualize that, okay, and think about your x. Which is longer, your x or your y? Which is longer? Well, it would be your x, okay? And that's why this is here, the square root of 3 over 2. Notice it's the same. They're both over 2. The denominators are both the same. Divided by 2, divided by 2. Well, let's look at what that square root of 3 number is. That's a little bit bigger than 1, right? So the square root of 3 over 2 is bigger than 1/2. So if I can now think about that, well, now I can say, okay, if you get those two mixed up, which one goes first, right? Well, think about where 30 is. Okay, at 30, what's going to be bigger, your x or your y? Well, it's your x. Okay, so therefore you can put the square root of 3 over 2 first, and then 1/2 second, because that's your y value. Okay, so that's how you can kind of think about it. Here's what I'll say about the unit circle. Everyone thinks about it in a different way. Okay, the way I think about it may not resonate with you at all. Okay, so you've got to find a way to really think about it. You've got to find which way works best for you. Okay, for some people, they just memorize this right here, and then think about those, the positives and negative coordinates. They literally memorize this. Maybe they don't understand it. Okay, that's okay. Honestly, if that's the approach you want to take, I'm okay with that. If you're just like, boom, I've got this quadrant down, and I just from there fill in the gaps, perfectly cool with me. Okay, but it's a brain thing, and you've got to think about what way works best for you. There are a million different ways to think about this on YouTube. There's got to be some explanation out there that works best for you. So I'll leave it to you on that, on how to understand it and know it. I don't recommend taking the memorization approach. It's too much to memorize. It's too much. I mean, look at it, right? Just count how many different pieces there are, right? Just in one quadrant, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 pieces, right? You multiply that by 4, ends up being like 100, right? So, or exactly 100. So it's just a lot of pieces. You don't want to memorize 100 things, okay? So memorize pieces of it and fill the gaps in from there. Okay, that's the unit circle. Now, let's look at some like exercises to where you're going to be using the unit circle to get values quickly. And that is this right here. Okay, I'm going to keep my unit circle handy, okay, especially when we don't know it in the beginning. Important to keep your unit circle handy. So let's go ahead and start with this. Okay, sine, I'm asking for what the sine of 11 pi over 6 is. Okay, well, let's look at it. We know sine is my y. Okay, so sine of an angle is the y coordinate. So let's go to 11 pi over 6 and look at it. 11 pi over 6, okay, found it on my unit circle. I'm looking for my sine, so that's my y. So this is equal to negative 1/2. That's what my answer is here. Negative 1/2. I'm done. Okay? But the goal is to be able to do that in our heads. Okay? The goal is to be able to do this in our heads, not using the unit circle at first. Not using the unit circle. At first, we can use the unit circle, though, because we've not visualized this yet, right? It takes a while. It takes some practice. It takes time to really understand this and have this in your brain in a way that makes sense to you, and you can be like, okay, where's 11 pi over 6? Okay, sine is my y. So what's my y coordinate there? How can I think about that? So that's the goal, all right? Now, let me say this too. Like, it may help to draw a picture. So I'm gonna show you, kind of take you through my process of a few of these and kind of show you how I would personally do it in my head. And then afterwards, I'll just confirm that with the unit circle, okay? So let's get some paper, though. All right, tangent of 3 pi over 4. Let's zoom. Tangent of 3 pi over 4. Okay, so maybe what I do is this. Where's 3 pi over 4? I've got to think about where 3 pi over 4 is. Okay, maybe you got your circle. All right, 3 pi over 4. Well, I know this is 0, this is pi. 3 pi over 4 is right here. Okay, it's looking for tangent. All right, it's looking for tangent. Well, I know this coordinate just off the top of my head, since it's one of those 45 pieces. Okay, that means it's, well, look, this is, my x is negative, my y is positive. So I actually know this coordinate here, just the coordinates, are going to be negative square root of 2 over 2, comma, square root of 2 over 2. Because that's my negative, positive part, right, quadrant. Okay, so for the tangent, right, that tangent was that third one, so it's this over this. Well, something over that same something, but it's negative. So negative 1 is my tangent 3 pi over 4. That's the process. Okay, notice how I didn't memorize it, but I used my pieces that I knew of the unit circle and got there quickly. Just to confirm, just to show you the visual of what we have just done. 3 pi over 4, there's my angle. There's my tangent, right? There it is, okay? Next one, cosine of 225. Okay, again, I'm drawing a picture. 225, let's figure where that is. Okay, 0, 90, 180, 270. 180 plus 45 gets me that 225, so that is here. Okay, it's one of those 45 pieces, so it's square root of 2, square root of 2, okay? But what are the positives and negatives going on there, right? Negative and negative, okay? So it's negative, negative. Got that coordinate. Cosine, that's my x, so it's this one right here. Now, they ended up both being the same, right? But it ends up being negative square root of 2 over 2, okay? Let's confirm it using this right here. It was 225. There's 225. Notice it was in degrees, right? It could also be in degrees. 225 is here. There it is. Negative, negative. Doesn't matter which one. It's cosine. Cool. Okay? So it's my x. It's my first one there. Sine of 45. Another 45. If you'll, the more you practice, the more you'll be like, oh, yes, a 45 one, right? Because it's less thinking. Okay? Sine of 45, though, let's draw it. Here's the 45 degree. Maybe you draw the circle too. There it is. That's my 45 degree angle right there. Okay, so that's the coordinate, right? It's square root of 2 over 2, comma, square root of 2 over 2. It's looking for sine, so I'm looking for the second one here. So it is the square root of 2 over 2, and we are done. Tangent of 240. Let's do this one. This is a tougher one. Okay, this is definitely a tougher one. So let's get our scratch work, though. Okay, tangent of 240. Maybe we quickly draw a circle. Okay, I've got 180. I've got 60 more. Okay, so I've got 60 more. So this is where it gets a little bit tough. I'm actually going to draw a bigger picture so we can see it. Really get the visual good on this one. Okay, cool. 240, that is somewhere right here. Just an approximation. Okay, so if we're thinking back up here, okay, the way I look at it, okay, is my y bigger or is my x bigger? Okay, is my y bigger or is my x bigger? Well, looks like my y is going to be the bigger one. So this is, the x is the negative 1/2. So, coordinate, negative 1/2, tiny, longer. Okay, so square root of 3 over 2. They're both negative because it's in that negative, negative quadrant. Okay, so it's negative 1/2, negative square root of 3 over 2. But it's looking for tangent. Okay, it's looking for tangent. So on this particular one, the tangent's a little bit funky, but you either know that it's square root of 3 or square root of 3 over 3. On this particular one, it's just the square root of 3. The way I think about this is the ones that are close to the y are just the square root of 3. Close to the y, just the square root of 3. Close to the y, again, square root of 3. Okay, so this one's going to be that second piece, the square root of 3. It's negative over negative, though, which gets you a positive. This one is positive square root of 3. And that is confirmed with this right here. Okay? A few more. Cosine of pi. Whew, that's easy. Okay? We'll do this one in our head. Visual, though, just to have the visual, it is important. Okay? Where's pi? Pi is here. What's my coordinate? Negative 1, comma 0 for that particular one. Negative 1, comma 0. Okay? It's looking for cosine. It's just negative 1. Cosine of 300. Here we go. New one. Okay? Coordinates. Circle. Where's 300? Let's find it. Okay? We've got 270 is here. So 30 more here. Just 30 more. There is 300. Okay? Got to think about where your x is in x and y, right? Your x is the small one. Okay? Your x is the small one, so, right? The reason why I'm saying that, 1/2 here, square root of 3 over 2 here, right? It's the small one, so it's the x is the small one. So 1/2 square root of 3 over 2. This is positive is your x, negative for your y. Okay? This one's looking for x, though, so it's just 1/2. Okay? Let's confirm it with the unit circle. it was 300. Here's 300. It's your x, so there you have it. It's 1/2. Okay? You could do that all the way around. Let's look at one of these examples where it's negative. Okay? Where like sine of negative 135. Okay? So this is tough. All right? This is a harder one because we actually want to convert this. Okay? We don't want negative angles, right? But remember, it's negative, right, has a positive coterminal angle is what we define those at, right? So if we just add negative 135 plus 360, okay, we're going to get, let's see, negative 135 plus 360, you're going to get 225. So this is actually the same thing. So sine of negative 135 is the same as sine of 225. The reason I'm rewriting this, these two angles are the same. Okay, those two angles are the same. That's why I'm rewriting it. Okay, so now we just want to think about 225. Okay, let's think about it. 225. Let's do this completely in our heads. Let's try to practice it. So 0, okay, you got the 180, right? And then you're adding 45 more to get me that 225. So you're adding 45. You're in that third quadrant, right? Got top right, top left. Now we're in the bottom left. They're both negative, okay? So I know it's going to be negative for sure. Since we're adding a 45, it's one of those 45 pieces. So it's going to be negative square root of 2 over 2. Okay? Similar here. All right, let's do that one. That one's tough. Okay? Negative pi over 6. We'll draw that one out to get another visual since we're still practicing. Okay? We've got, here it is, negative pi over 6. So, boom. That's the negative pi over 6. Right? Is that close to the x-axis? Or is that close to the y-axis? Remember, the ones that are closest to the y-axis, that's the square root of 3, right? And then square root of 3 for your tangent. So that one's far from it. So it's going to be square root of 3 over 3. Question is it positive or negative now? Well, this is your quadrant where it's, your x is positive, but your y is negative. So it's going to be negative square root of 3 over 3. That's the logic that has to happen for going into this. Okay, to confirm it, there it is. It's your negative pi over 6, which is right here. Positive coterminal radian would be 11 pi over 6, right? So 11 pi over 6 is equal to negative pi over 6. And we do end up with that negative square root of 3 over 3. All right, now, let's change it up a little bit. But this doesn't add too much, okay? I'm going to practice one or two of these, okay? It's really almost the exact same as what we just did. In order to find these, it looks complicated, right? Like it's just a lot looking at it, okay? But it's really not, because all you're essentially doing is you're going to find the corresponding one, and then you're going to flip it. Like, that's it, okay? You're just going to flip it, and then you may need to get rid of a radical, but, could be worse. Okay, so I'm just going to pick a random one. Let's do the first one. Okay, so 7 pi over 4. We got to think about where 7 pi over 4 is. Almost at 8 pi over 4. We're just taking away one more. So that's going to be right here. That's 7 pi over 4. Okay, it is asking for cosecant. So which one does that correspond to? Well, cosecant corresponds to sine. Sine is your y. Okay, so you got your y here. It's negative square root of 2 over 2. But now I'm going to flip that. Okay, so it's 2 over the square root of 2. Negative 2 over the square root of 2. But what do I have? I have a radical on the bottom, so I've got to get rid of that radical. So that's what I'm going to do here. Multiply by square root of 2 over the square root of 2. And it's all going to equal negative square root of 2, a negative 2 times the square root of 2, but then over 2, so it ends up just being that right there for this one, okay, square root of 2. So you go to the corresponding one, right? If it's cosecant, you're going to sine. If it's secant, you're going to go to cosine for that particular angle. You're going to find what it is, and then you're going to flip it, okay? And that's what it says here, right? So it says find each value. So first find the sine, cosine, tangent, and then you flip it, okay, which is the reciprocal part. Okay, so let's do secant of 2 pi over 3. secant of 2 pi over 3. So here we go. 2 pi over 3, where's that? That's here. Okay. Secant, well, which one corresponds to secant? Cosine corresponds to secant. Okay. Cosine corresponds to secant. Okay. So here we are. My cosine is negative 1/2. This one's a little bit easier, right? Because we found the corresponding one. Here it is, right? So cosine 2 pi over 3, that's negative 1/2. But now we're just going to flip it. So it ends up just being negative 2, right? Because if you flip negative 1/2, it ends up just being negative 2, okay? So that's that process there. Be careful on that because you may have to get rid of the radical like I had to do in that first one. That is it for today. Now, let me say this. The unit circle is daunting at first. Takes a while, okay? It's not without practice, right? Like, it's a tough piece in this class, okay? But it is the most important thing that you learn in this class, like, to be completely honest. If you walk away from pre-cal and you haven't learned anything, if you walk away from pre-cal and you got to pick one thing to learn, this is it. Okay, it's the most important piece. It's the one that really continues into calculus big time. Has so many implications for calculus and other things. It's just one of those pieces, right? Like it's like your multiplication table. Right? At some point, the multiplication table is hard to know, hard to understand, hard to remember all of them. Same thing with this. Okay, it's just one of those things where you got to get there. You got to train your brain to visualize it, and that's it. Okay, lots of different ways to think about this. I know this was a long video. Thank you for being patient. But it is all important and stuff we will need to move forward. Hope you guys have a great day. See you later.